Hi, my name is Corey Wadeen, and today my partners Amy Stores and Tyler Tucker and I are going to be going over Chapter 15, Analyze Telemetry and to Better Anticipate Problem and Achieve Goals. Well, we're going to begin with the introduction. Today we're going to be going over the Netflix theory of standard deviation, the use of standard statistical models to detect problems and statistics, create instrument and alert on undesired outcomes, analyze problems that may arise from telemetry data, and create models to manage anomaly detection techniques. The first one we're going to go over is how standard deviation works with Netflix. Well, Netflix is a huge application that works with millions of users. And in order to make it run properly, there needs to be a way to detect errors or problems within the system. One of the statistical techniques that the team at Netflix uses is outlier detection. Outlier detection helps run and service problems that run within the program. It is a very simple way to compute what was the current normal and what is an outlier. Rappaport, he claims that we can automatically flag misbehaving nodes without having to actually define what the proper behavior is in any way. And since we're engineered to run resiliently in the cloud, we don't tell anyone in operations to do something. Instead, we just kill the sick or misbehaving node and then log it or notify the engineers whatever form they want. Now, Rappaport, he also claims that Netflix has massively reduced the effort of finding sick servers and, more importantly, massively reduced the time required to fix them. This was all done by using standard deviation. Netflix is a very successful company, and other internet companies or streaming services are going to follow in its footsteps. This leads us to the use of means and standard deviations to detect potential problems. As we know, there are many ways that standard deviation can help the programs that people are working on. For example, if people are working on a program and they want to know, for example, how many times somebody logs in before it alerts them, they can set an alert for 3 login fails. Now, it is important that we set this alert because that could show us that that is the standard deviation from the norm. This is a common use of standard deviation. On to Amy Stores. She's going to talk about the next section of the chapter. Go ahead, Amy.
Thanks, Corey. The next step after we are looking to detect our issues is, of course, to alert on these issues. So we're looking to find those indicators that are prediction of an outage and alert on those specific things, because if we try to alert on everything, then we're going to develop some alert fatigue, and by then the alerts will mean nothing because there's so many of them. So one of the best ways to find what we need to alert on is to look at the most recent past. So for example, the last 30 days, and see what our problems were, and then look back to see what could have predicted those problems. And those are the items that we need to alert on. So when we're looking at that, we need to look at the main 4 levels: our application level, our operating system level, our database level, and our network level. So then we can create alerts that are meaningful and that we can act on. And as we do this, we can actually refine the process to find those predictors earlier in the process so that we're not getting alerts as things are failing, but way before they would fail, so that we can fix those issues before the customer will see any issues when they're working with our systems. So now we're going to have some problems when our telemetry data doesn't have a normal bell curve. So what we're going to see is that our normal standard deviations won't apply. So the graphs that we're going to see, example, the one on the right, is actually going to show us that we would be constantly alerted. So that's not really helpful to us. So we have to see that over alerting is going to cause our engineers to be woken up at all hours for issues that they may actually not be able to solve, as it may be a hardware issue or a software glitch. So these might be things that they can't fix. So we actually have to look at other techniques to look at detecting these anomalies, and that is actually going to come next. So we're going to let Tyler take care of that. But first, we're going to look really quick at the case study for Netflix on auto-scaling capability. So Netflix actually developed a tool called Skyer, which actually predicted the demands that the customers would need. And it was based on the historical data that they had gathered. So it addressed three main problems. So dealing with rapid spikes in demand, because the system could already predict that. It would know, for example, Black Friday, and that would need to have more capacity than, say, a Tuesday at 10 p.m. So the next thing that it actually did was, after an outage, that rapid decrease in customer demand would actually lower the capacity. Well, it actually needed to be prepared for a higher capacity with all the customers attempting to go back and hit the site. So it was able to predict that and accommodate for what demand that was about to happen. And the third thing was that AAS didn't factor in traffic patterns when it was scheduling the computing capacity, but the system could actually fix that issue so that the correct capacity would be available when needed. So how did it do this? It actually used a combination of outlier detections, FFT, and linear regression to smooth out the data. And in result was that Netflix can actually forecast the traffic demand with really high accuracy and thus make it so that their services are available to everyone and they have less outages and downtimes. So, as we were talking about before, we're going to pass this over to Tyler and let him finish it up for you.
All right, so we will cover next using anomaly detection techniques. Anomaly detection is the search for items or events which do not conform to an expected pattern. So the goal is to detect anomalies by using data that we've gathered and analyzed from various perspectives, using statistics, analytics, charts and graphs, certain equations and software like Tableau or R, various other methods of analysis. And we want to be able to use these various perspectives so that we can have a greater ability to pick up on these anomalies. In conclusion, we want to remember to use statistics and statistics models to find anomalies, to hire people on our teams and train everyone on the team to be a problem solver and an analyst, and make sure that we have the tools that we need to be able to understand data from a big picture perspective as well. To use smoothing, forecasting, and other tools and softwares to have more accurate and easy to read data to be able to cover our bases